Ever wondered how artificial intelligence is reshaping the invisible infrastructure that powers your phone, satellite signals, and 5G networks? Let's dive into a groundbreaking development that's pushing AI beyond general knowledge and into the realm of specialized engineering. TeleMath, the first benchmark dataset designed to test AI's ability to solve math-driven problems in telecommunications. Here's the challenge. While large language models like GPT-4 or LLMA excel at general tasks, they often struggle with the precise, step-by-step reasoning required for telecom engineering. Think of it like asking a generalist chef to design a molecular gastronomy dish. Sure, they know cooking basics, but the nuance. That's where TeleMath steps in. So how was this dataset created? Researchers partnered with subject matter experts, telecom engineers and physicists, to craft 50 foundational problems, from calculating signal loss over distance to optimizing network traffic. But here's the innovation. Instead of static questions, they developed a system to generate hundreds of variations through problem decomposition. Imagine disassembling a smartphone to understand its components. Similarly, each core problem is split into subproblems, then encoded as executable code or symbolic math formulas. For example, a question about signal-to-noise ratios might generate a Python script that calculates this value across different frequencies. This ensures the dataset isn't just a test, it's a dynamic training ground for AI. But why prioritize numerical answers over symbolic ones? In telecom, engineers need exact values, like the precise signal strength required for a 5G tower or the optimal data rate for a network. A symbolic answer like SQRT, X, might look correct, but it's useless for real-world applications. TeleMath's focus on numerical outputs ensures results are actionable, measurable, and directly applicable to engineering workflows. Now, let's break down a real-world example. Suppose we're calculating free space path loss, PL, the signal degradation as radio waves spread out. At 3.5 gigahertz over 0.2 kilometers, the PL formula gives us 89.35 decibels. That's a 100,000-fold signal loss. But engineers don't stop there. They calculate receiver noise power, background static, and determine the required received power for a 15 dB signal-to-noise ratio. The math shows the transmitter needs just minus 12.9 dBm, about a thousandth of a watt. But here's the twist. The transmitter's EIRP, effective isotropic radiated power, must stay within legal limits. Even with a weak transmitter, antenna gains can amplify the signal. In our example, the EIRP is minus 8.8 dBm, well under the 23 dBm threshold. This balance of power, distance, and noise is the heartbeat of wireless communication. And how do AI models perform? When tested on TeleMath, generalist models like GPT-4 struggled with domain-specific reasoning. But reasoning-focused models, designed to break down problems step by step, excelled. It's like comparing a puzzle-solving expert to a giant robot with vast knowledge but no strategy. The expert wins every time. But TeleMath isn't just a test, it's a roadmap. By making this dataset public, researchers are creating a tool to train AI that thinks like engineers, methodically, precisely, and with domain-specific expertise. This matters for real-world applications, from 5G network design to satellite signal optimization, where errors can have massive consequences. Of course, no study is perfect. The dataset started with 50 core problems, and while it covers traditional telecom engineering, areas like 5G protocols or AI-driven network management are underrepresented. Also, some questions were generated using a specific AI model, which could subtly favor its performance. But the team has implemented safeguards to ensure fairness. So what's the takeaway? TeleMath isn't just about AI. It's about redefining how machines learn to solve technical challenges. It's a step toward AI that doesn't just memorize facts, but reasons like humans, breaking down complex problems into logical steps. Thanks for watching. If you want to explore how AI is transforming fields like engineering, physics, or data science, hit subscribe for more deep dives. And if you've ever wondered how your phone connects to the internet, remember, it's not magic, it's math, physics, and a little bit of AI. Stay curious.